If you have a plane, so if we're in 3 dimensions, x, y, and z, one of the important surfaces to try to talk about are planes. So here's a plane, and something that characterizes a plane is the normal vector, which is the vector pointing directly out of the plane, which is orthogonal to the plane, perpendicular to the plane. Which, when we say it's perpendicular to the plane, what we mean is if you take any vector in the plane, so take any vector from this point to another point in the plane, let's call this vector v, and this vector over here w, then v cross w, sorry, v dotted with w is equal to 0. And that's what it means for this vector, the vector w, to be orthogonal to the plane, or to be normal, to be the normal vector. And so then when we're trying to write the equation of the plane, using the following intuition, using this intuition over here, what we can say is, okay, take a normal vector, so a vector normal to the plane, take a vector normal to the plane, dotted with some vector in the plane. So let's call the vector in the plane, let's call it, so let's imagine that this is the point x0, y0, and z0. So that's this point over here. And then we're looking for this vector. And this is the vector pointing to any other point in the plane. So it's the vector pointing to any other point x, y, z. But there's some condition on this, and the condition is that the dot product of this with the normal vector, so the dot product of the vector going from x0 to x, so it's going to be x minus x0 y minus y0 z minus z0 is equal to 0. And this is going to be the equation of the plane. So let me erase this and we can rewrite the equation of the plane. So again, if we have a normal vector, so here's our normal vector n, and it's, let's say, the vector a, b, c, and it's the vector orthogonal to our plane. And then we are trying to describe our plane. So we can say that the normal vector dotted with the vector x minus x0, y minus y0, z minus z0 is equal to 0. Any questions about this?
What is this equation used for?
This so far is the first step to how to figure out the equation of a plane. The equation of a plane is the set of all these vectors such that they when we dot them with your normal vector, you get 0.
Okay, thank you.
All right. Okay, so then that tells us that the vector a, b, c dotted with x minus x0, y minus y0, z minus z0 is equal to 0. And now when we open up the dot product, we get a times x minus x0 plus b times y minus y0 plus c times z minus z0 is equal to 0. Okay. So now we're going to continue here. This tells us that ax plus by plus cz is equal to ax0 plus bx plus by0 plus cz0. So in general, what we say is that ax plus by plus cz is equal to d. And this is the equation of a plane. So the way to read this plane is that the coefficients before the x, the y, and the z, these coefficients, they make up the normal vector. So if you put them together, you get a, b, and c, which is the normal vector. So you know that this vector is orthogonal to your plane. Anytime you see a plane like this, you know that this vector that you can read off from the coefficients is orthogonal to the plane. And then the way to figure out this d over here is by taking one point that you know might be in your plane and plugging it into your x, your y, and your z, and seeing what d is. So we're going to do a few problems to see how that looks in practice, but those are the major strategies of how to look at a plane. So here, let's look at how the book describes a plane, and then we're going to try to look at some examples. Any questions about this? Okay, so again, if you want to describe a plane through a point x0, y0, z0 with a normal vector a, b, and c. So here's your normal vector, here's your point x0, y0, z0, and you want to describe a plane at this point. Well, what we're going to do is we're going to look at the point P, which is any point x, y, z on the plane, and we want that the normal vector dotted with our vector going from P0, where P0 is the point x0, y0, and z0. So we want the P0, the vector going from from P0 to P. So here's P, that's equal to 0. Which, like we said, it means that if we take that vector and we dot it with this vector over here, and again, this vector is the vector P0P. So that's going to be equal to 0, which means that we can take the A, B, and C, multiply each one of them individually, which means we get AX plus BY plus CZ is equal to AX0 plus BY0 plus CZ0. And that gives us the equation of the plane. So, like I said, in general, if I were, for example, if I were to tell you I have a plane with a normal vector, so I'm going to give you the normal vector, and the normal vector is going to be the vector 3, 1, 0. And then I'm going to say, so if I just gave you this vector, there wouldn't be no way for you to figure out the specific plane that that has this normal vector, because there are many planes that have this specific normal vector. You can have this plane over here, but then you can move this plane up and you can have this plane over here. And they both can have the same normal vector, because the normal vector is just the vector pointing out of the plane, vector orthogonal to the plane, and they both have the same normal vector. So you need a normal vector, but you also need a point, and that was the point x0 that we talked about, or x0, p0, sorry, y0, z0. So you need a point p0, and it's a point on the plane. So if I gave you this normal vector, and then I gave you the point p0, and I said, okay, p0 is going to be the point 1, 0, 0. And then I said, okay, find the plane with this normal vector containing this point? Well, you're going to know immediately that the plane is going to look something like 3x plus y plus 0z, so plus 0, no z, is going to be equal to d. Now again, the question is, what is d? So let's plug in this point to get our d. So that's going to be 3 times 1 plus 0 is equal to d. So now we got our d. Our d is going to be equal to 3. So that gives us that the plane is 3x plus y is equal to 3. And that is a plane with this normal vector. It does have that normal vector. You just read it off and you see that it does. And it does contain this point. So any questions about this? Yeah, is it clear?
Do you mind explaining the last part real quick again?
Yeah, so um, when you read off the coefficients for the normal vector, you put them in front of the x, y, and the z. And then in order to figure out your d, what you can do is you can take the point they give you. They always give you a plane. Generally, I mean, whenever you have a plane, you need a normal vector and you need a point that the plane contains. Those are two pieces of information that you need. Otherwise, there are many different planes that you might have conditions. So there might be a bunch of different answers. Anyway, so you need a normal vector and you need a point. So you take this point and you plug it into your plane, and you want to satisfy that the condition that comes out of that. So that would tell you in this situation that 3 times 1, the x coordinate, so 3 times the x0, plus 0 times the y coordinate, so here's y, plus 0 times the z coordinate is equal to your d. So that's what your d is going to be. So then you just,
Okay.
yeah. So that tells me that d is equal to 3. So that's my d.
Oh, that makes sense now. Thank
Okay.
you.
Any other questions? Okay. So, like I said, every plane has the vector form n dotted with some vector. In general, actually, you should think about it as a times x minus x0, b times y minus y0, c times z minus z0, and that also gets you to ax plus by plus cz is equal to d, where, like we said, d is equal to ax0 plus by0 plus cz0. So again, you can plug in your p0 is equal to x0, y0, z0. So you're really, when you're trying to find your d over here, you're really plugging into your x and your y and your z. You're plugging in x0, y0, z0. So that's why your d is equal to ax0 plus by0 plus c0, z0. Okay, so this plane over here is a plane with a point p0 over here and a normal vector over here. And the normal vector is 0, 0, 3. And okay, so that's basically what they're trying to show you over there. And yeah, okay. So now they're asking us to find the equation of the plane through the point P0, which is the point 3, 1, 0, with the normal vector 3, 2, negative 3. So we already know that this plane is going to have the form 3x plus 2y minus 5z is equal to d for some d. And now in order to find what the d is, you just use your P0. So there will be 3 times 3 plus 2 times 1, and then minus 5 times 0 is equal to your d, which will get us to 9 plus 2 is equal to d, which gets us to d is equal to 11. So this is equal to 11. So that just, yeah, it tells us 3x plus 2y minus 5z is equal to 11. Yeah, any questions about this? Okay. So another thing that appears a lot on these type of tests is trying to be able to figure out whether two planes are parallel. So like I said, if you have two planes with two different normal vector, with the same normal vector, you can have two planes with the same normal vector, and those planes would be parallel to each other. So if you want to figure out whether two planes are parallel to each other, you honestly just have to look at their normal vector. And if they have the same normal vector, then you know that they're parallel. So let P have the equation. So this is one plane. And we want to find the equation of the plane parallel to P, that one is passing through the origin and two is passing through this point over here. So let's first try to do the one passing through the origin. So again, we just need to find the number d over here that satisfies that. So that would be 7 times 0 minus 4 times 0 plus 2 times 0, and that's equal to 0. So the equation of the plane that is going to pass through the origin is going to be 7x minus 4y plus 2z is equal to 0. So that's the equation of the plane that passes through the origin. Now, what about the equation of the plane that passes through Q? So again, you do a very similar thing. Second, yeah. So we have 7 times 2 now, and then we are going to have minus 4 times negative 1, and plus 2 times 3. And this is going to be equal, and I'm going to cheat now and just look at, okay, what they do. So that's 24. And, okay, so then the equation is going to be 7x minus 4y plus 2z is equal to 24. And this is the equation that passes through the point B. Any questions about this? Is it clear?
It's making sense.
Yeah. Okay. So now another thing that in general we can do with planes is following. Second. So if we have 3 points in space, so here's x, y, and z. So if we have 3 points in space, 1, 2, and 3, then we can think of the, first again, we can have a triangle. We can also think of the plane that contains these 3 points. And there's only one plane that contains these 3 points. And we would like to be able to find this plane. And the way we do it, well, okay, so let's imagine that this is the point P, this is the point Q, and this is the point R. So we first find the point PQ, so the vector from P to Q. We also find the vector from P to R. So those are these vectors. Now, in order to find the normal vector, we just have to find a vector normal to both of these two vectors, and that's going to be the cross product. So this is PQ cross PR. So that's another vector that we look for, and this is the normal vector. PQ cross. And this is equal to the normal vector. And that's basically it, because then we know that, well, again, we know that the vector, sorry, the equation of the plane is ax plus by plus cz is equal to d. And we know what a, b, and c are from the normal vector over here. And we can figure out what d is by plugging in the point, by let's say taking the point p is equal to the point p0, which is equal to the point x0, y0, z0. So let's see an example for this. Actually, I'm gonna give an example, and then we're gonna try to see if they give an example as well. So let's take our points. Let's imagine we want to find a plane through the points P is equal to the point 0, 1, 1. Q is equal to the point 2, 1, 1. And R is equal to the point 1, 0, 0. So now we want to find the plane that goes through these points. Okay, so first we want to find the vector PQ. The vector from P to Q. So that's going to be the vector Q minus P. So that's 2, comma, and then 1 minus 1 is 0, and then 1 minus 1 is 0. So that's the vector PQ. Next, we want to find the vector PR. So that's going to be 1 minus 0, which is 1, and 0 minus 1, which is negative 1, and 0 minus 1, which is negative 1. So far in our diagram, what we've done, this is x, y, and z. So here are our points, P, Q, and R. So we found the point, the vector PQ and the vector PR. And now we want to find the cross product in order to find the normal vector. So this is the normal vector. So what is PQ cross PR? So that's going to be equal to IJK, and then 2, 0, 0, 1, negative 1, negative 1. And then this is going to be equal to I times, and then you're going to have the matrix, this matrix, which is going to get us to 0. And then minus J times, and then you're going to have negative 1, sorry, negative 2, and then minus 0. So it's just going to be negative 2. And then plus k times. So then you're going to have just negative 2. And then this is going to be equal to the vector 0, 2, negative 2. So yeah, well, it's orthogonal to this vector for sure. If you take the dot product, you get 0. It's also orthogonal to this vector. So it's probably correct. Anyway, so now what do we do? So if we have, so this is the normal vector. So once we have the normal vector, we can say that our plane is going to have the form 0x plus 2y minus 2z is equal to some number d. Okay, so that gives us that 2y minus 2z is equal to d. And now we can let's plug this in to see what we get. So if we plug that in, we get that 2 times 1 minus 2 times 1 is equal to d, which is equal to 0. So d is equal to 0. So let me just erase this part. So let's try that. So 2y minus 2z is equal to 0. Let's see. So the first one is a point in the plane, because if you plug in 1 to y and 1 to z, you do get 0 over here. The second one is also, if you plug in 1 to y and 1 into z, once again, you're going to get 0. And also the third one, if you plug in 0 to y and 0 into z, once again, you're going to get 0. So these 3 points are in this plane. So it ended up working out. Any questions about this?
Professor, what if you plug in, when you're looking for the value of D, what if you plug in Q or R?
Yeah, so you can plug those in too, and you're going to get the same thing. So in this case, the form of your plane, the equation of your plane, is 2y minus 2z is equal to d. If you plug in q, you're going to get 1 and 1. So you plug in 1 over here, you're going to get 2 times 1 minus 2 times 1, which is 0. So your d is going to be 0 again.
Okay, yeah, so basically it's all points on the plane, right?
Yeah.
Thank you.
Yeah. Yeah, because this, we already found, well, yeah, once you already have your 3 points and you find the plane that goes through one, with your normal vector, you already establish your normal vector with the other points, you know that it will go through the other points as well. So you know that if you find the d for one of them, you're going to find the d for the other one as well. Okay. Any other questions? Okay. So let's look at their problem. So they want us to find the plane determined determined by the 3 points, so P, Q, and R. So again, like before, we want to find the point, the vector PQ. So that's the vector going from P to Q. And so that's the vector 2 minus 1, which is 1, and 2 minus 0, which is 0, and 1 minus minus 1, which is 2. So 1, 2, 2. And then the vector PR, and that's going to be the vector. So 4 minus 1 is 3. And 1 minus 0 is 1. And 2 minus 1 is 3. So yeah, 3, 1, 3. And now, in order to find the normal vector again, we take the cross product. So PQ cross PR is equal to the determinant of IJK 1, 2, 2, 3, 1, 3. And this over here is going to be equal to I. And then we have 2 times 3, which is 6, minus 2, which is 4, minus j. So now for j, we're going to have 3 minus 6. So that's going to be minus 3. But then with this minus, so this will become plus, and this will be 3. And then we're going to have plus k times, and then we're going to have 1 plus 6. So that's going to be, minus 6. So that's going to be minus 5. Okay, so this is going to be equal. So our normal vector is going to be 4, 3, and negative 5. Now, in order to find D, we just plug in one of these points. So let's plug in the point P. So we have already that 4x plus 3y minus 5z is equal to D. So 4 times 1, and then 0, okay, and then minus 5 times negative 1, so plus 1. This is equal to D, which is equal to 9. So that tells us that 4x plus 3y minus 5z is equal to 9, and this plane is the plane that contains these 3 points. So you can actually try to verify it. You can plug in your q, and you can see. So that for q, that would be 4 times 2 plus 3 times 2 minus 5 times 1. And this is going to be equal to 8 plus 6 minus 5, which is equal to 9. So check. So that point is in the plane. And also the point R should be in the plane. So that's the basic strategy for finding the equation of a plane that passes through 3 points. Find the normal vector by, first find the 2 vectors going from one of these points to the other 2. Then find the normal vector of those 2 vectors. And then find D by plugging in one of these 3 points. Are there any questions about this? Okay, so let's look at the next problem. The intersection of a plane and a line. So they want you to find a point P where a certain plane, and a line intersect. So the one thing that you need to know in order to do this type of problem, the one thing you need to remember is how to write x of t, y of t, and z of t for your line, because that you remember to do that, then in this example, let's look at this problem. We would have x of t is going to be equal to 1 and then minus 2t. Y of t is going to be equal to 2 and then plus 0t, and then z of t is going to be equal to 1 plus t. And now we can plug these into our plane. So we can plug the x coordinate into the x, and the y coordinate into the y, and the z coordinate into the z. So let's see what happens when we do that. So when we do that, we get 3 times 1 minus 2t, and then minus 9 times 2, and then plus 2 times 1 plus t. And if we set this equal to 7, we can now solve for t. Okay, so when we simplify this, we get 3 over here minus 6t minus 18 plus 2 plus 2t is equal to 7, which gets us to, so you're going to have 3 plus 2, and then minus 18 is going to be, sorry, 1 second. Oh yeah, it's going to be negative 13. Yeah, it's going to be negative 13. And then this is going to be negative 6t and then plus 2t. So that's going to be negative 4t. So get negative 4t minus 13 is equal to 7. Okay, and so then you can move the 13 to the other side, and you get that t is going to be equal to negative 5. Because you get 20, and then the negative goes to the other side. So we know when the plane and the line intersect. The plane and the line intersect at the point where t is equal to negative 5. So let's draw a picture of what we've done so far. So first, they gave us a plane. So here's a plane and a line. So here's the line. And it goes through the plane at some point. Intersects the plane at this point over here. And we want to know what this point is. So again, every plane has an equation ax plus by plus cz is equal to d, where my normal vector is equal to the vector a, b, c. And in order to find the point d, I take a point on the plane and I plug it in as x0, y0, and z0, and into this equation, and I get my d. Now, in order to find this point over here, the point where the line and the plane intersect, what I can do is first I can look at the equation of the line. So every line has the equation r of t R of t is equal to P, well, let's say R0 plus TV. And this is equal to some vector x of t, y of t, z of t. So now, what we can do if we want to find where these points intersect is we can take these components and plug it into our vector. So now we're looking at A of xt plus B of yt plus C is equal to D. And this is just something in terms of t, so you can solve it. And when we solve it, we get t is equal to some number. And in our case, we got t is equal to -5. And that means that if you walk along this line, at t is equal to -5, that's when we hit the plane. So that's t is equal to -5. So that's what this means over here. When we got t is equal to -5, it means that when this t is equal to -5, that's the point where we hit the plane. So if now we want to figure out what point that is, we just need to plug in our -5 into the x, the y, and the z. So that's the next thing that you do. So when you plug it into x, you get x is equal to 1 minus 2 times -5 right? And this is equal to 11. And you get that y is equal to 2. And you get that z is equal to 1 minus, and so now for t, when you plug in -5, you get -5. And this is equal to 4, or sorry, -4. So you get that so this is the point where your line and your plane intersect. So we get that the point where they intersect, the point P, is going to be 11, 2, and -4. So that's going to be the point P. 11, 2, -4. So any questions about this? Okay, so let's run quickly through what they did again, and then we're going to stop. But when you have a point P, when you're trying to find a point P of where a line, where a plane and a line intersect, what you do is you open up, you look at the components of your line, and you plug it into your plane. So for the x, you plug in the x component. For the y, you plug in the y. And for the z, you plug in the z. So that's the x part, that's y, and that's z. And now you're going to have them all in terms of t. And then you try to solve for t, which should be fairly straightforward. I mean, because a plane is linear. So you should always be able to solve for t in these type of situations. So now you can solve for t, and you get the time when the line intersects the plane. And then you take that time and you plug it in for your t in your x coordinate and in your y coordinate and in your z coordinate. And you get the point where the line and the plane intersect. Any questions about this? Yeah, is it clear?
It's clear.
Okay, so if you have any questions or you want to go over any of the material, please send me an email. And next class, we're going to talk more about the upcoming test. Okay, have a nice day. Bye.
Thank you.